In this section, we'll take a look at the configuring and monitoring protocol-independent routing objective of the JNCIS Service Provider exam. We'll examine how to configure static routes, routing instances, and how to enable load balancing. For more detailed coverage of this objective and more, please check out the JUNOS Intermediate Routing course. In this video, I'm going to be demonstrating some static routing concepts. But before we get into the specifics of the static route configuration, let me just give you a background to the lab that we're going to use. And we're going to reuse this lab on multiple occasions when it comes to demonstrating some of the concepts that are going to be associated with the JNCIS Service Provider exam. We're going to use this lab to demonstrate protocol-independent routing concepts. We'll take a look at ISIS and OSPF on this lab. We'll have a look at BGP on this lab, and we'll also use the lab to demonstrate MPLS concepts. So to give you a bit of an overview of what we're looking at here, R1 through R6, the blue routers here, are going to be the main autonomous system that we're focusing on. And R1 through R6 are all going to speak the same IGP, and they're going to be speaking IBGP with each other and MPLS protocols as well. And then we have XR1, XR2, and XR3, and they're going to be speaking eBGP to our internal network here, so that we've got some external destinations to play around with. And we'll turn to this lab again and again to illustrate some of these routing concepts for this group of videos aimed at aiding your revision for the JNCIS Service Provider exam. One key point of background to note is that I've actually deployed this lab on one VMX, on one virtual MX, and each of these routers is a logical system on that VMX. So if you see logical systems mentioned in some of the configuration hierarchy, you can basically ignore that. Where possible, I've tried to make the lab look like 9 separate routers. So please just treat each of these devices as a completely logically separate router, and we'll interrogate them as such when we use operational commands. So that was a bit of background onto the lab topology that we're going to be using. Now let's focus in on static routes. And we're going to be looking at static routing from the perspective of R1. And we'll configure a static route to R3. And we'll also look at configuring some aggregate routes. So let's now get in and start the configuration process. See, I'm logged into R1 now. Let's have a look at his routing table. There's not a huge amount in there. You see that we've only got one address in the 192.168 range, and that's our own loopback address. And what we want to be doing here is adding a static route to R3's loopback, which is 192.168.1.3. Can we ping this address first? I think you all know the answer. Obviously we can't, because we don't have any route to it. So what we're going to need to do is we're going to need to add a static route to this IP address. First, we need to know the next hop that we're going to use. So we're going to be using this interface to R3. Let's have a look at this interface. So you've got a /31 on there, and we're going to be using 10.0.1.9 on this address. If you want to confirm what the next hop needs to be, you can always do a show up, and you can see 10.0.1.9 is on this interface. So let's add a static route to this. See, we have that static route added. Let's apply that configuration. Have a look at our routing table. Now we can see that that static route is in our routing table. Can we now ping R3's loopback? Yes, we can. So our static route configuration was successful. So let's finish this video off with configuring an aggregate route. So if you remember that aggregate routes are used to summarize routing on devices, and we would use them to represent multiple routes before advertising them upstream to upstream routers. And aggregate routes need contributing routes in the routing table before they're going to be generated. So let's just first demonstrate this by creating an aggregate route that doesn't have any contributing routes on this system. So this aggregate route, 192.168.10/24, we don't have any more specific routes in 192.168.10, so we shouldn't expect this route to appear in the routing table when we commit this config. We've committed the configuration, and there is no route for this aggregate in the routing table, even though we have that aggregate route configured. So let's now create an aggregate route that does have contributing routes in the routing table. So we are aggregating the loopback range. Let's commit that configuration. Do we now have an aggregate route in the routing table? Yes, we do. See it there. And if we have a look at this route in more detail, there you can see that we have two contributing routes to this aggregate, which are allowing it to be generated. And that's how you configure static and aggregate routes. In this video, we're going to take a quick look at routing instances. We're going to configure a routing instance on R1, and we're going to put the interface facing R3 into this routing instance. And we're going to see how that affects which routing table we use to ping R3 and R4. And we'll also take a look at how you can use rib groups to copy additional routes into routing instances. So we're on R1 now. Let's have a look at the routing table. And it's fairly basic. The main routes that we're concerned about are these. They're the routes that are facing R3 and R4. And see, we can ping R3 and we can ping R4. So let's now create a routing instance, and into it we're going to place the interface facing R3. So let's call it routing instance R1 to R3. The first thing we need to do is specify an instance type. And you can see here there are an awful lot of different instance types, and they all serve slightly different purposes. But the one that we're concerned about here is just segregating the routing tables on a router. And to do that, we use the virtual router routing instance type. We then need to specify the interface that we're going to place into this routing instance. And we're looking at the R3 facing interface. So it's going to be this interface here. Let's have a look at the configuration we're going to commit. And let's commit that configuration now. And let's see what effect this has had on the routing table. So we now have this extra routing table present. If we look at the main inet.0 routing table, you can see that 10.0.1.8/31 and /32 routes, they are no longer present in this routing table. And they have been moved to this new routing table, this R1, R3 inet.0 routing table. And these are where our interface routes that are facing R3 now reside. Let's see what effect this has had on our ability to ping R3 from the main routing table. See, we can no longer ping R3 from the main routing table because the route isn't present in the main routing table. So what we can do is we can specify that we want to use a different routing table to source our ping with the routing instance flag. And we're going to specify this routing instance. And now we can ping that IP address. If you want to interrogate that specific routing instance to see what routes are in it, you can do show route and then use the table flag. And see, we can see our two interface routes that are facing R3 in our R1, R3 routing instance. We saw that we couldn't ping R3 from the main routing instance. Can we ping R4 from within the R1, R3 routing instance? No, we can't. And obviously that's because the routes facing R4 are not present in this routing instance. So what you can do here, instead of moving that interface into the routing instance, if that interface had to stay in a different routing instance or in the master routing instance for some reason, what you can do is you can copy the interface routes into this specific routing instance. And we can do this using a rib group. So let's create a rib group and apply it to interface routes to see what effect this has. What this rib group is saying is that we're going to, wherever we apply this rib group, we want routes from that source to be imported into both this rib and this rib. So let's have a look at the configuration so far. We've got our rib group created. We now need to apply this to a source of routes. In this case, we're specifying interface routes. So we now have our rib group created and applied to interface routes. So let's commit this configuration. We're now taking another look at the R1, R3 inet0 routing table. And you can see that the interface routes facing R4 are now present in this routing table. They've been copied into there by virtue of this rib group. So let's see if we can now ping R4 from the R1, R3 routing instance. And we can. So that was how you configure the most basic settings of a routing instance and how you can copy routes using rib groups. In this video, we're going to be taking a look at load balancing on Juniper devices. We're going to be doing this from the perspective of R3. and we're going to be looking at the route to R6. As you can see from this network diagram, R3 has two equal cost paths to R6. And we're going to see what the routing table looks like by default on R3 and see what changes happen when we turn on per packet, i.e. per flow load balancing. So let's get down to the configuration now. So we're logged into R3. Let's have a look at the route to R6. You see that we've got two next hops for R6 in our routing table. But let's take a look at the forwarding table and see what that looks like. Well, we've only got one of these next hops programmed into the forwarding table. We've chosen one at random, that's this one here, and it's been programmed into our forwarding table. And so obviously this is not ideal because we're not using all of the capacity that we have available to us. So as we talked about in the theory videos, to get the router to per flow load balance over these equal cost next hops, what we need to do is turn on the per packet load balancing flag in the forwarding table. And we do this with a policy statement. So let's configure the policy statement now. Let's call it LB for load balance. Let's not specify any routes. Let's apply it to all routes. So let's immediately have a then action, load balance, and per packet. That's all we need to do with the policy statement. The final step we need to take is we need to apply this policy statement. And we're applying it to the forwarding table on export. Let's apply this configuration now. So we've still got those two next hops listed to the 192.168 1.6 route in the rib. Let's have a look at the fib. Now you can see we actually have two next hops programmed into the forwarding table, and they're associated with the route via an intermediate unicast list. And this means that we are going to load balance traffic across these two interfaces when we send traffic to this IP address. And this was showing you an example of how you change the load balancing style on a Juniper router.